Welcome in this video, and here we are going to explore more ways in which we can apply differentiation. In this case, we are going to learn on how we can sketch a curve using the gradient function. Now, in our previous video, we did an example where we were trying to find stationary points. We did an example where we identified the points at which the curve turns. That was the maximum or the minimum. But we did not really find the nature of the curves, whether they open upwards or they open downwards or they are inflections. Now, if you look at these curves or illustrations right here, we notice that we have a maximum, we have a minimum, or an inflection point. So in this example here, we are going to learn on how we can determine whether it is an inflection, a minimum, or a maximum point. So the first thing we do is to find the gradient function and set it equal to 0. The reason is because we know at turning points the gradients are always 0. So the first derivative for this function of y, so y prime is going to be equal to 2x plus 6. And we are going to set this equal to 0. 2x plus 6 is equals to 0. And 2x is equals to negative 6. X is equals to negative 3. So our first task will be to find the value of y at this point, so that at least we find a stationary point or a point. Now, finding a point is going to help us to be able to sketch the curve. And therefore, the value of y at this point is going to be equal to negative 3, we square that, plus 6 multiplied by 3, negative, plus 4, that is going to be 9, plus negative 18 plus 4, and this is going to be negative 9 plus 4, which is negative 5. So the stationary point for that is equal to, the stationary point is going to be x, which is negative 3, comma, negative 5, comma, negative 5. So that is the stationary point. The next thing we need to know is, does it open upwards or does it open downwards, or is it an inflection? So for us to do that, there are two ways of doing that. First way, we can use the second derivative to determine whether it is a maximum or a minimum. But if you don't want to use the second derivative, which we are going to do in another video, we can use a small table here. We can use a small table here with the value of x at this point, and then we have the nature of the curve. We have the nature of the curve at a point where the gradient is 0, and the nature of the curve where the curve is, so this is going to be dx dy over dx. So we're going to have the value of x that we are going to use is this. The value of x is going to be negative 3 here. So we're going to know to the left of this curve, is it a negative, or is it a positive gradient or a negative gradient? And therefore, we're going to say negative 4, and to the right of this point is negative 2. So we're going to insert these values. Of course, if we insert negative 3 in our gradient function, definitely we are going to find 0. Therefore, the gradient is going to be 0. Now, what about if we insert negative 4 in our gradient function? So if we insert negative 4 in our gradient function, we're going to have 2 into negative 4 plus 6, and that is negative 8 plus 6, and that is negative 2. Now, negative 2 is a negative gradient, and a negative gradient is drawn like this. So that is a negative gradient. Now, if we insert negative 2 in our function, that is going to be 2 multiplied by negative 2 plus 6, and that is 4, and 4 is a positive gradient. So you notice that this is going to be a minimum. The curve will open upwards. And therefore, if I want to sketch my curve here, I'm going to have a simple Cartesian plane. We know the point is negative 3, negative 5. Negative 3 will be around here. 1, 2, 3. 1, 2, 3, 4, 5. The point is going to be around here, and that is going to be the minimum, and therefore it's going to open upwards. It's going to open upwards, and that becomes the shape of our curve. It is a minimum, and this point is -3, -5. And that's how we can sketch a given curve. So in our next video, we are also going to learn a way in which we can sketch this curve using the second derivative without drawing that table over there.